Hello viewers, in today's class we are going to discuss one important concept from three-dimensional geometry with the help of one example, right? So here we'll discuss the concept of intersection of a line and a plane, right? So here we have this problem, that is, find the point where the line x minus 1 over 2 is equal to y minus 2 over minus 3 is equal to z plus 3 over 4 meets the plane 2x plus 4y minus z is equal to 1, right? So here we are given the equation of a line and the equation of a plane, right? So here we have the plane, say pi, this is 4, and we have the equation of the plane as 2x plus 4y minus z is equal to 1, right? Okay, so let us draw a rough diagram here. Suppose this is a plane and we have a line. We can draw the line like this, right? So suppose this is the line, and here this is the point, say P, where this line L meets the plane pi, right? And suppose the coordinates of this point P are, say, alpha, beta and gamma, right? And we need to find out the coordinates of this point P, which is the point of intersection of this line L and the plane pi, right? So let us see how we can find out the coordinates of the point of intersection. So here we'll make use of the equation of the line, right? And here we'll use the concept of a general point on a line, right? So general point on a line, right? So what we do, see here we have the equation of the line L, right? And here let us equate these three terms to some numbers, say lambda, and where lambda is some scalar or some real number, right? So what we have done here, in order to find out the coordinates of the general point lying on a line, we equate these three terms to lambda, right? And we'll find out the values of x, y and z in terms of lambda, right? So what we will do, we'll write x minus 1 over 2 is equal to lambda, then y minus 2 over minus 3 is equal to lambda, and then z plus 3 over 4 is equal to lambda, right? So we'll form three equations, right? So from here x is equal to 2 lambda plus 1, from here y is equal to minus 3 lambda plus 2, and from here z is equal to 4 lambda minus 3, right? So we have got here the values of x, y, z as 2 lambda plus 1, then minus 3 lambda plus 2, and 4 lambda minus 3, right? And for some value of lambda, we have the point P, right? See, this point lies on the line L, right? For different values of lambda, right? And for some unique value of this scalar lambda, we'll get the point P, right? So let us equate this point to the point alpha, beta and gamma, right? So alpha is 2 lambda plus 1, beta is minus 3 lambda plus 2, and gamma is 4 lambda minus 3 for some lambda, right, belonging to the set of real numbers, right? So now see, this point P lies on the plane pi, right? Because P is the point of intersection of the line L and the plane pi, right? So this point must satisfy the equation of the plane, which is 2x plus 4y minus z is equal to 1, right? So this point P satisfy the equation of plane, right? Equation of plane. So we have for x we can write alpha, for y we can write beta, for z we can write gamma, right? So we have 2 alpha plus 4 beta minus gamma is equal to 1, and alpha is 2 lambda plus 1, so we have here 2 lambda plus 1, then we have plus 4, beta is minus 3 lambda plus 2, and here we have minus gamma. Gamma is 4 lambda minus 3, that is equal to 1, right? So now we have a linear equation in lambda, and we can easily solve this equation. So we can write 4 lambda plus 2, then we have minus 12 lambda here, 4 3 is the 12, and we have 8 here, then minus 4 lambda plus 3 is equal to 1. And now we'll collect the terms containing lambda. So 4 lambda get cancelled. Here we have minus 12 lambda. This is 2 plus 8 10, 10 plus 3 13 is equal to 1. So this is minus 2 lambda is 1 minus 13. So this is minus 12 lambda is equal to minus 12. So lambda is equal to minus 12 over minus 12, that is lambda is equal to 1, right? So now we have got lambda is equal to 1. Now, to get the coordinates of alpha, beta, and gamma, we can substitute the value of lambda is equal to 1 in this coordinate, right? So alpha is 2 lambda plus 1, so this is 2 times 1 plus 1. Beta is minus 3 times 1 plus 2, and gamma is 4 times 1 minus 3, right? Okay. So now this is 2 plus 1, 3. This is minus 3 plus 2, that is minus 1. And this is 4 minus 3, that is equal to 1, right? So the coordinates of the point of intersection of the line L and the plane pi is given by 3 minus 1 and 1, right? So this is how we can find out the point of intersection of a line and a plane.